Okay, good day, B Form 4 students. Let's see if I can do this again. This is how to calculate a dose using the Simporedose PK dosing calculator. So this calculator is really based on all the equations that I've given you in the class, and it helps you. You don't actually have to do the calculations, but you need to know how to use some type of software to be able to predict the dose for a patient. So it consists of three regions. The first region is those in the blue section of these blue blocks, which you fill in the data. Then it consists of a calculator, so it'll calculate an answer here, the T max and the D maximum maintenance dose. And then thirdly, in this section here, you would put in realistic doses, and it would calculate the average plasma concentration, the maximum plasma concentration, the minimum plasma concentration. So that's really what you need to do. So let's take, for example, we'll put in here that 90 micrograms per liter is the maximum that you need to go to. Anything above that we see as side effects, and the minimum here would be, say, for example, 40 micrograms per liter. You then need to add in the elimination rate constant. In this case, you need to note that you have to do the positive value, not the negative value that's calculated. So let's say we put in 0.0660. So first order elimination rate constant, and you'll notice there it calculates the hours as 10,5 hours is a half-life. Put in the fraction availability, let's say 0.75. No, that's not 0.75. 0.75 is a fraction availability, and parent volume of distribution 192 liters. So it's quite bound to tissues. So those, and then using these parameters here, it will calculate the Tmax, which is every 12.26 hours, and the maximum maintenance dose in micrograms, which is 12,800 micrograms. So if we give 12,800 micrograms every 12.26 hours, we will stay between 90 and 40. But of course, you can't give that as a dosage. So let's say, for example, this tablet comes in 5 milligram tablets. It's a small little tablet, you can't split it. So we look here, so 12,000, the closest there will be about 5 milligram tablets. That's 10 milligrams or 10,000 micrograms. So add in 10,000 micrograms. Let's try, for example, every 12 hours, and you put in 12 hours. Calculates the average is 49, the max is 71, which is below the 90, which is fine, but the minimum of 32, unfortunately, is below the maintenance. So let's see if we give it more often. So give it every 8 hours. Fortunately, now it goes above the maximum. I mean, it's above the minimum, but it also goes above the maximum. So now what do we do? So let's try one tablet. Whoops. 5 milligrams every 8 hours. And you can see, well, it's way below the minimum. So we'll have to increase that frequency. So let's give it every 6 hours. And once we go to every 6 hours, we go above the minimum of 40 and below the maximum of 90. So the dosage for this would be 5 milligrams every 6 hours. You can try, of course, you can see because it has a wide therapeutic window, you can give 5 milligrams every 4 hours, and it'll still be below the max and above the minimum. It'll be much higher up in that therapeutic window. And if we don't need to go higher up in the therapeutic window, it's best to give 5 milligrams every 6 hours, because it's better for the patient. Less often the patient takes a tablet, the more they comply with it. And if it's not that, and we don't want to go too close to the max, because we might start to have side effects. So for this tablet here, based on these pharmacoparameters you have here, we would give this tablet 1 5 milligram tablet every 6 hours. And that's how you calculate the realistic dose. Good luck for your exams. I hope this is recorded.